everybody. Welcome to the lesson on the two-sample t-test. Before we get into that, though, we are starting the module or the unit on between groups designs, or sometimes called between subjects designs. And so I want to spend a minute telling you what that means. So a between groups or between subjects design compares values, and almost always we're talking about means, across independently sampled groups. If it's not a between group design, the contrast to that is a within groups design or a within subjects design. The difference there is that in a within groups design, we're really looking at one sample with multiple values collected on the same individuals. Whereas with the between groups designs, we've got different groups, different groups, and we're comparing values across them. So I've got some examples here, and we'll talk about which ones between and which ones are within. So for a sample of books comparing the hardback price to the ebook price, this one is within groups. And that's because we've got one sample of books, but two different measurements on each one of them. Second example, comparing student grades in an 8 a.m. section to the student grades in a noon section of the same course. That's going to be between groups because we've got completely different individuals in the 8 a.m. class to the noon class, and they're not paired up in any way. Third example, comparing the athlete times to complete a race at different points in the season. So maybe at the beginning of the season, midway through, and then at the end of the season. So that's going to be within groups. Because again, we've got multiple measures on the same individuals. And then comparing mean starting salaries of Queens grads by college, that's going to be between groups. Because we're going to have different students who have graduated with degrees in the McCall School of Business versus the College of Health versus the other ones. Okay? So we're going to focus first on between groups designs, and we'll be doing that for a couple of weeks. And then we're going to look at within groups designs. So our first between group design is the two-sample t-test, also called the independent samples t-test. And this one is used for comparing two group means. And I specified here that the groups are independently sampled. That just means it's a between subjects design. So we've got two groups that are sampled. So we took a sample, we got a bunch of one group and the other group. I won't make up an example right now. Then we want to compare those means. I want to show you in SPSS, this data is going to look maybe not like you would expect. Your data is going to be in two columns. You might expect to see a column with one of your groups that you're going to compare to and the other column with the other one, but that's not the way this data looks. The example we're going to look at here in just a minute is in this attention span data. We're going to be comparing attention spans for boys versus girls. And what this looks like is we've got all the attention spans in one column, and then in another column we've got whether the child is a boy or a girl. Okay, so we don't have attention spans for boys in one column and then for girls in another column. We have to arrange it like this for SPSS. There are other programs that'll let you give you more flexibility on that, but SPSS is not one of them. So one way you could look at these two variables is to say that the group membership, in this case whether the child is a boy or a girl, is your independent variable. And the numeric values, the attention span, would be the dependent variable. We generally think of the independent variable predicting the dependent variable. And that's really what we've got going on here. We can't say it's cause and effect, but we want to know if basically being a boy or a girl has a bearing on your attention span. The two-sample t-test does have an assumption that each of the two groups is normally distributed. So we have to check normality, but we have to check for the first group as well as the second group. We do have the same thing we had before, that the test is robust against mild departures from normality, provided both sample sizes are large. So that's going to allow us to, that's going to give us a little forgiveness for the normality assumption. The hypotheses, we've got two groups. We'll call them group 1 and group 2. The null hypothesis is that the two groups are equal in mean, and the alternative hypothesis can be that one of them is less than the other, and that can go either way. Or you can have the two-tailed option, which is not equal to. So just like before, this one is two-tailed. And these two are one-tailed. And I'm not even going to give you the formulas. They're kind of nasty looking formulas. You can look them up online if you want to see them. We're just going to get them from SPSS. I should mention that there are two options for the independent samples t-test or the two-sample t-test. You can pool the variances or not, and that's just a detail about how the test statistic is calculated. The key here to know is that pooling the variances assumes that those population variances are equal. So it assumes sigma 1 equals sigma 2. Which is actually those are phrasing it as the standard deviations, but it's the same thing as if you squared both of them, that would be the variances. So that's this option. The other option does not have that assumption. Because unpooled does not have this assumption, it's considered to be the more conservative approach. And that's the one we're going to use. So use unpooled. Okay. Some researchers use a test, which you'll see on your SPSS output, to determine whether there are unequal variances, and then they'll use that to determine whether to use pooled or unpooled. That's not a good idea for multiple reasons. Levine's test is not all that effective of a test. So So we'll just always go with the unpooled option. But I wanted you to know this so that, if you're at some point see this, I don't want you to say, my teacher taught me wrong. Because a lot of statisticians would say don't use Levine's test. Let's go ahead and we'll come back to effect size. But let's go ahead and look and start with our example. So if we run, so we're first going to test our assumption of normality. So we're going to analyze descriptive statistics, explore. And we're going to take our numeric variable, which in this case is our attention span. And we're going to put that in the dependent list. And the gender of the participant goes in the factor list. Don't get those backwards of each other. Your output won't look right if you do. But remember, we want the numeric variable in dependent list. And then our factor list is our categories. And under plots, we want to turn off the stem and leaf, turn on the histogram, and turn on the normality plots with tests. So I'm going to click continue and then click OK. And let's see what we have. All right. So for the male children, we've got a skewness of 0.534 and a kurtosis of negative 0.548. Those look good. For the female children, we've got a skewness of negative 0.117 and a kurtosis that looks a little platykurtic, negative 1.536. It's not too far out. Let's see where the tests of normality point us. Okay, the test of normality, Kolmogorov-Smirnov, for both groups has a p-value of 0.2. So it looks like, according to Kolmogorov-Smirnov, neither one of these groups departs significantly from normality. With such small sample sizes, it's hard to see much from the histograms, but those certainly don't look super normal. The normal probability plot doesn't look too bad. This is for the males. Yeah, it doesn't look too bad for the females either, though. Let's take a look. We don't have any outliers. So, all right. So yeah, I would say the assumption of normality has not been violated. All right, so that's our assumption. I'm going to write down here what our steps are in SPSS. We're going to go to Analyze, Compare Means, Independent Samples, t-test. So Analyze, Compare Means, Independent Samples t-test. And we're going to, before we do this, you always need to check what the values are on your grouping variable. So you're going to want to go over to your variable view and look and see what these values are. Sometimes they're zeros and ones, sometimes they're ones and twos, sometimes they're something else. So we need to know that these are ones and twos. So going back to Analyze, Compare Means, Independent Samples t-test. Our test variable, that's our numeric variable, is attention span. And our grouping variable is gender. And you see where it's got the question marks? This means it's waiting for us to tell it that we've got 1s and 2s. So we're going to click on Define Groups. And tell it Group 1 is 1 and Group 2 is 2. And we're going to click Continue. And we're going to click OK. And so we get this output that's got our sample sizes, it's got our means and our standard deviations, and it's got our, let me point this out to you here. I'm going to copy this over. I'm going to pause. All right, I had to pause that because the record button was in the way of getting to the snipping tool that I needed. So I'm going to take this and I just did a little snip of the SPSS output so I can write on it. All right, so we've got a lot of stuff here and we don't need all of it. So this Levine's test is the one I was telling you is not good. So ignore it entirely. Okay. So what we're left with here is equal variance is assumed and equal variance is not assumed. If you remember, we said we don't want to assume equal variances. So ignore all of this. This is what we want. And it's really just this much. So our test statistic is negative 2.429. And our p-value, and this is for the two-tailed test, is 0.02. Okay, so those are the only two values you really need from all of this. Okay, the thing people get wrong is they'll try to use this because they'll see this as the first one that's listed. Okay, so don't use this. This is just a test to see if the variances are equal. So if we were to run this and write it out the way we've been doing it with the with the hypothesis test notation and all that, we would say Group 1 is males, and Group 2 is females. And they're asking us to test whether there is a difference. So we're going to have H0, colon, mu1 equals mu2. Versus HA or H1, mu1 is not equal to mu2. And we get our t-test statistic as, what did we say that was? Negative 2.429. And a p-value of 0.02. Yeah. And we're going to reject H0 if the p-value is less than alpha, or 0.05. This p-value is less than 0.05, therefore we will reject H0. And say that there is sufficient evidence to conclude boys and girls have different mean attention spans. I won't write all that out. I'll just say that mu1 is not equal to mu2. Okay? Now, for this test, to calculate Cohen's d, the formula is you just take the difference in the sample means, take the absolute value, and then divide by the larger of the two sample standard deviations. Okay, and essentially this is telling you how many standard deviations apart the two group means are. Okay, so if we look back at our output, so that we can calculate Cohen's d, we need 6.2955 is the one mean. The other mean is 9.0278. That's a 0 there. And we're going to take the absolute value and we're going to divide it by the larger of the two standard deviations. The larger one is 3.6804. You don't have to write 4 decimal places. If you want to write, just 3, as long as you round it correctly, that's fine. I can get a little bit, I can go overboard sometimes with decimal places, as my college professors can attest. By the way, one shortcut, a minor one, but still a shortcut, is you see here where it says mean difference in the output? That is 6.2955 minus 9.0278. So they're doing the that top part for you. So we're going to do this on the calculator. And you take the opposite sign of that because it's negative. If it's positive, you just leave it positive. And so we have an effect size of 0.74. We'll just call it 0.742. So 3 decimal places is fine. The reason we did the larger of S1 and S2, if you take the smaller one, you're going to get a larger effect size than if you take the larger one. Wait, I can't remember if I said that backwards. If you take the smaller effects, the smaller standard deviation, you're going to get the larger effect size. If you take the larger standard deviation, you're going to get the smaller effect size. We want to be cautious, conservative, and when I say conservative, it's in the sense of not wanting to overstate our conclusions. We'd rather be on the cautious side when making our claims. So the reason we pick the larger of the two is so that if we've got two possible values to choose from, we pick the smaller effect size. I'm giving you the rough guidelines here with the same caveat as before, which is be very careful how you interpret these. Don't just, blindly go 0.742 is large, because it's closer to large than moderate. And by the way, these are, if you've got something in between moderate and large, it's okay to say it's fairly large or moderately large. If you've got something between small and moderate, you can call it small to moderate. You can call it, medium rare. No, that's not right. But you get the idea. And just like before, we're only going to report this effect size if we've got something that is statistically significant. Okay. So we've got all of our elements. We're going to do our write-up, and we want the same stuff as we had last time. So the same elements in our write-up. We're going to need to tell what we did. Well, let me just show you this that I've done. And just like before, this is not something for you to just, copy and change the numbers on. This is to give you one example of something that's an acceptable write-up. And we'll practice in class with some other examples. All right, so we start with a statement of what we're doing. So we say an independent samples t-test was used to compare attention spans for boys and girls. And then we do our assumptions. And so we look at our assumption of normality, which looks like there was no significant departure from normality. So we're good to go on that. And then we state our descriptive statistics. We state our sample size, our sample means, and our sample standard deviations. And one thing I did not do here that I'm going to do now is report the minutes. Put the units on here, which in this case are minutes. And then finally, we want to talk about the results of the test. So we said that the test was statistically significant at the 0.05 level. And then, in parentheses, we stated our test statistic and our p-value. And then we stated our effect size and interpreted it as large. Okay. Sometimes people will put inside the parentheses, comma, D equals 0.742. I just put it outside this time because we're still learning about effect size. Okay. So again, with the effect size, this tells us a yes and. This tells us, yes, we can conclude there's a difference, and it looks like it's a pretty big difference. If you're talking about a difference between 6 minutes and 9 minutes, that's pretty substantial. All right, so that's it for this lesson. One thing I'll mention before I close is that at this point, there gets to be a lot of hypothesis tests, and people get them confused. So I would recommend creating a document where you kind of keep a summary so that you know if I want to compare a mean to a constant, that's going to be a one sample t-test. If I want to compare two group means to each other, that's a two sample t-test. And that way you know where in your notes to look. Because that can be the hardest part, is figuring out where to start. Alrighty. So as always, if you have any questions, let me know.